Welcome to aminacademy.com and theory of equations regarding absolute value or modulus of a complex number. Look at this. Here, this is xy plane. X axis is the real axis. Y axis is the imaginary axis. This is a point that is represent a complex number a plus bi, where a is the x distance, b is the y distance. This length, that is O to origin to that point, is called absolute value of that complex number, distance from origin. Now, the absolute value or modulus of a complex number z equal to a plus bi, where a and b are real numbers, is the distance from the origin 0, 0 to the point AB in the complex plane, calculated modulus of z equals square root of a square plus b square. Look at here. Now, a complex number z represented a plus bi. Here, where a equal real part of a plus b, we can represent r of bi, a plus bi. Then b is the imaginary part that you have to represent I of a plus bi. Here's some detailed explanation. Complex plan. What is complex plan? Imagine a plan where the horizontal axis represents the real part of a complex number and the vertical axis represents the imaginary part. Complex number representation. A complex number z can be represented z equal to a plus bi, where a is the real part and b is the imaginary part. What is the modulus or a distance? The modulus of or a absolute value of z is the distance from the origin to the point a and b on the complex plan. This is the modulus. This distance is the modulus. Here used is Pythagorean theorem. This distance can be calculated using the Pythagorean theorems, like here modulus z equal to square root of a square plus b square. Now let us do some theorems and properties of absolute values of a complex number. This absolute value or a modulus of a complex number z equal to a plus bi is its distance from the origin in the complex plane, calculated where z equals square root of a square plus b square. Here some key theorems on properties related to the modulus of a complex number. Definition: the modulus of a complex number z equal to a plus bi is defined as modulus of z equal to square root of, that is modulus z equal square root of real part square and imaginary part square. The modulus representation the distance of the complex number from the origin to the complex plan, that point in the complex plan. Modulus of a product. Here, suppose modulus of a complex number z into w is equal modulus of z and modulus of w separated. Modulus of quotient, right? Modulus of z over w equal modulus of z over modulus of w, where w is not 0. Modulus of your power. Look at here. Here, modulus of z power n is modulus of z power n. That is inside the modulus here, here outside. That means modulus of z power n is equal to modulus of z whole power n. Modulus of a conjugate. Here, modulus of z equal modulus of z conjugate. Both are equal, where z is the complex conjugate of z. Triangle inequality. Here, modulus of z plus w is always lesser or equal to separately modulus of z plus modulus of w. Relationship to conjugate. Z and z is the complex number, and conjugate, its conjugate is z bar, that is z into z bar equal modulus of z the square. Modulus of a sum of a complex number. Here, modulus of z1 plus z2 is lesser or equal to modulus of z1 plus modulus of z2. Modulus of a difference of a complex number. Modulus of z1 minus modulus of z1 minus z2 is greater or equal modulus of z1 minus modulus of z2. Here, for addition, it is lesser or equal or subtraction, it is greater or equal. Note this point. So far we discussed simply about theorems and properties of absolute values. What is absolute value of the complex number? We have done. Please subscribe our YouTube channel.